Bismillahirrahmanirrahim. Auzu billahi minash-shaytanir-rajim. This is the part 2 of the intrusive corrosion monitoring in oil and gas. Continuing the previous video, this slide shows the corrosion coupons, the principle and monitoring. Principle is a physical technique. It's a direct, intrusive, offline technique. Metal lose weight when undergo corrosion. The coupons are installed parallel to fluid flow. Monitoring. It monitors the weight loss, stress-assisted corrosion, bimetallic galvanic attack, differential erosion, heat-affected zones, sensitivity of this weight loss corrosion coupon monitoring is only 0.1 millimeter per year. This slide shows how corrosion rates are measured from coupon weight loss data. The top expression shows the corrosion rate in mils per year with this constant 22,300 times weight loss. The whole of this is divided by the area in square inches, density in gram per cubic centimeter, and time in days. The lower equation shows the corrosion rate expressed in millimeter per year. The 3.65 times 10 to the 5 is a constant times the weight loss in grams, area in millimeter square, density in gram per cubic centimeter, and times in days. This slide shows the shape and type of the corrosion coupon holders. On the left is the low pressure coupon holder. On the right is the high pressure coupon holder with the different type of coupons as well as the scale coupons and the disc coupons. It also shows the safety clamps, which is very important to use when you are using the low pressure coupon holders. The low pressure coupon holders, the insert is only controlled by the packing glands in the nut. So in case there is a high pressure or the pressure is more than the holding capacity of the packing glands in the nut, the insert can escape, right, and cause the leakage of the system. In order to keep the insert in the same place and to make the thing safe for the unit as well as for the people around, all the low pressure coupon holders are used with the safety clamp. This slide shows a corrosion monitoring by electrical resistance technique and its principle and monitoring. Its principle is there is a physical technique, a direct intrusive online technique. It measures change in electrical resistance of a metal element. Its conductive cross-sectional area changes as a result of corrosion, erosion, or by erosion corrosion. Metal elements shape can be as a strip or a loop or tube loop or wire loop or rod or ring. It can be stored online or when stored side stream, it provides real-time measurement when sufficiently sensitive probes are used. The monitoring meter works on the principle of Wheatstone bridge. It's monitoring the corrosion rate as mils per year. It's a delta dial over delta days times 0.365 times probe span. Its sensitivity is less than 0.1 millimeter per year. It's online monitoring technique. The principle is that the resistance is equal to the resistivity of the metal, its length, and its area, cross-sectional area. As the cross-sectional area changes, the resistance changes, and the resistance is inversely proportional to the cross-section area. So as the area decreases, the resistance increases, which measures actually the rate of corrosion of the metal. This slide shows corrosion monitoring by electric resistance technique, its benefits and limitations. Benefit of this technique is that it can be used in oil, gas, water, or emulsions. It's a high resolution technique and fast. It measures the corrosion rates direct. It can be continuous monitoring, right? It's quick to response. It can be used to trigger alarm if the corrosion rate is set in there as a part of your program. It evaluates inhibitors more effective and faster than the coupons. Even the opportunity crude means sometimes you're processing one type of the crude, and next time you're processing other types of the crude, and if the crude rate changes because of the crude change, this technique can easily monitor and reflect very fast the change in the rate of corrosion or the corrosivity of the crude. Limitations are time and temperature dependent. It only results in sour system. In sour system, this technique does not properly work. It gives the corrosion trend only, it does not give actually the what normally happens on the surface of the material and how the corrosion rate changes at the surface of the facilities. Element life is limited to 50% consumption. As the life reaches 50%, then the dilute oil starts giving you the erroneous result. It's not representative of the corrosion on pipe or the vessel wall. It gives the average corrosion rate. Installing a retrieving probe at the bottom of the line requires extra space, quite a logistic challenge. Thin elements are more sensitive than the thick elements. Seals may need to be compatible with the actual fluid and environment. Its sensitivity is about 0.1 millimeter per year. This slide shows low pressure corrosion monitoring ER probes. The low pressure retractable or removable under pressure system is called the 1-inch full port wall mounting system. It is limited to less than 1500 psi. This shows the shape of the low pressure fitting which is installed onto the vessels or the pipes or the facilities in there. Although its pressure rating is given as to 1500 psi, normally it is better to have it in a lower pressure, but 1000 plus, to have a safety margin in there. On the right, you have the fixed non-removable under pressure probes. The one is the thread mounting probes, other is the flange mounting probe. This slide shows high pressure corrosion monitoring ER probes. High pressure corrosion monitoring ER probes are normally called 2-inch HPAF mounting. The rating starts from 1500 psi to 6000 psi. Now, better higher pressure rating probes are available on demand up to the pressure rating of 10,000 psi. These probes are retrievable under a pressure system, means that you don't have to shut down the system to retrieve or install these probes. The representative corrosion stream, the normal and debris-free flow, they are actually used in a system where there is no erosion effect. Because erosion effect is there, these probes lose their service life and their actual configuration very fast. It causes no flow restrictions and turbulence in the system, right? It's better to use a corrosion shield when these probes are installed because they are very thin probes in there, and in order to avoid any impact of the fluids or the erosion impact on the surface of the probes, these probes are normally protected by a erosion shield. The probes are installed perpendicular to the flow without shield. But it's better to have a shield in there, then you can install the probe as you wish. High pressure inner probe look different, like a wire type, like a loop there, wire loop, strip loop, cylindrical type, and the another type in there, and the all the different types of the probes are available, and you have to choose which one is more suitable for your facilities. In order to choose the probe or the selection of the probes and other critical matter, and only a very experienced consultant or a corrosion engineer can decide which type of the ER probe you may require for your system. This slide shows how the ER probe, the high pressure ER probe, installed into the pipe. The orientation of the probe during installation is very, very important. If the erosion shield or velocity shield is not used during installation, but it's always better to use the erosion shield to avoid any orientation effect. Actually, these probes are installed perpendicular to the fluid flow so that each surface of the probe or the surface of the actual loop in there, which is facing the fluid flow, must have an equal impact on the fluid flow. So it's very, very important when as you install these probes that you fix the orientation by making a mark on the top of the solid plugs so that you can use a fixed orientation or use the velocity shield to avoid this type of restriction using the erosion shield. This slide shows another technique based on the inductive resistance, its principle and monitoring. Principle is mass changes in the sensor element are detected by measuring changes in the inductive resistance of a coil located inside the element. Inductive resistance offers opposition to the flow of alternating current caused by the inductance and capacitance in a circuit rather than by a resistance. Monitoring it, corrosion rate monitored just as ER. This slide shows the benefits and limitations of the inductive resistance. Benefits are more sensitive than ER technique, less affected by the temperature than the ER technique. Limitation is it has to measure a uniform corrosion only. It does not give any information on the localized corrosion. It requires a temperature compensation as ER to avoid a temperature effect. This slide shows how the corrosion is monitored by a linear polarization resistance technique, its principle and monitoring. Principle is the direct intrusive online technique. It works on the principle of direct current electrochemical. Polarize the electrons to plus minus 10 to plus minus 20 millivolt from corrosion potential. Average of corresponding current is measured to calculate the corrosion rate. 2 to 3 electrode systems are used based on the resistivity of the electrolyte. It monitors on the basis of the Stern-Geary equation, which is explained in here, where this B is the anodic taper slope, BC is the cathodic taper slope, E is actually the I corrosion times 2Rp plus Rs. Rp is the polarization resistance, which you measure as a slope from the straight line in between plus minus 20 millivolt. R is SA is the solution resistance between anode and cathode. Corrosion rate is calculated from the use of Faraday's laws. This technique shows the linear polarization resistance corrosion monitoring, its benefits and limitations. Benefits are instantaneous technique means that it measures the corrosion rates direct without any calculations. You just plug in the meter into these probes installed into the system and you can just monitor the corrosion rate. It has a high resolution. You can even install the continuous monitoring system and you can find out how the corrosion changes on the continuous basis. It gives the direct corrosion rates without calculations. This technique is used to measure the pitting index. It doesn't measure the pitting rate. It only measures the pitting index. It means that you can compare the pitting index with the previous reading and obviously with the incoming readings. And you've come to know that how the actual pitting index changes means that how the pitting rate or corrosion is changing, but it does not give you the pitting rate. In process sensitive means that if the pressure or the flow regime is changed, right from streamline to turbulence or other ways, the instruments is more affected and it gives you a higher corrosion rate. It can be used to evaluate the inhibitors. It can also be used to trigger the system of the injection pumps. If you have a system installed in there which is linked with the injection pump, and as you fix the corrosion rate, if the corrosion rate exceeds than the fixed corrosion rate, it can trigger up the injection pump which can inject more inhibitor into the system. It is cost effective. Its limitations are it is conductivity dependent, meaning the system cannot be used in gases or in non-conducting system like ER. It needs a continuous aqueous phase, so in the entire surface of the probes has to be immersed in the liquid. It is Tafer slope dependent, it's a corrosion potential dependent. Corrosion trend as corrosion data may not be representative of the corrosion on the pipe or the vessel wall. It's also localized corrosion dependent. It's also fouling dependent, means when the probes they become dirty or fouled, this system start giving you the erroneous result. This slide shows how these LPR probes look like. On the left you have the two electrodes, LPR probes, the two cylindrical electrodes or the two disc electrodes. The disc electrodes, you can install them as flush in the system. The three electrodes having a test electrode, auxiliary electrode, and the reference electrode. The three electrode system is used where the conductivity is low. This slide gives you the LPR probe selection, conductivity chart plus the low and high pressure LPR probes. On the left you see the conductivity chart or the LPR2 or 3 electrode selection. It gives you the operating range and the non-operating range for the LPR probes, and also gives you the operating range for the 2 electrode system and the 3 electrode system. On the right you see the configuration of the low pressure LPR probe and the high pressure LPR probe. This slide shows the LPR probe installation location and orientation. The installation should be done at a place where the fluid stream corrosive characteristics are more representative. These probes can be installed on the side stream or direct into the fluid through the piping or the vessel walls. Electrodes face the flow in identical manner. This is very important that both electrodes or the three electrode system, they should be installed in such a way that both of them are equally impacted from the fluid flow. The normal debris and the flow regime affect the performance of the LPR probes. LPR probe causes no flow restriction and turbulence downstream of the installation. These electrodes are the LPR probes. Electrodes should be fully immersed into the electrolyte. Orientation shown on the right, whereas the recommended installation is there, where the both electrodes are facing the incoming fluid flow in such a way that the both electrodes they get the equal impact of the fluid flow, means they should be installed perpendicular to the fluid flow. The installation of the electrodes as parallel to the fluid flow is not recommended. This can also be installed as a side stream or from the side as shown in the lower diagram on the right side of the slide. This technique is based on the zero resistance ammeter. Its principle in monitoring. This technique measures the galvanic corrosion of the system where the more than one metal are in both electrolytic and electronic contact right in the system. Principle is that it's a direct current electrochemical technique. It's direct intrusive online technique. Two electrodes of similar or dissimilar metals immersed in the process fluid. A potential gradient develops because of the corrosion in there, and current flows between two electrodes that is measured by this resistance ammeter. Small active metals are as per galvanic series corrodes. The monitoring depends upon the flow of current is monitored as the measure of corrosion. It also means the galvanic corrosion and the oxygen corrosion. This right-hand slide also shows the shape and configuration of the probes in there. One shows the galvanic flush probes, the other one shows the galvanic cylindrical probes. This slide shows the benefits and limitations of the zero resistance ammeter technique. Benefits are the high resolution technique and fast technique. It measures the galvanic or bimetallic corrosion. It can identify the crevice and pitting attack. Can also identify the corrosion assisted cracking, corrosion by highly oxidizing species as well as the weld decays. It can also measure the oxygen corrosion. Limitations are the defined anodes and cathodes has to be there. Like a system has two metal like copper and iron, the probes must be made from the copper and iron likewise. Is not fully representative as overall galvanic corrosion depends on relative area and geometry of the anodes and the cathodes. Iron drop limited as well. If the electrolyte resistance is high, then the current measurement is not the representative of the corrosion. Correlation between the measured current and oxygen concentration is approximate, not exact. It cannot distinguish between anodic and cathodic control corrosion rates. It's only qualitative for measuring the pitting corrosion tendency. This slide gives you the sand probe system, which can measure the erosion and corrosion of the system. Its principle and monitoring. Principle is a physical, direct, intrusive online technique. It detects sand erosion in real time. Placed in the center of the line means that the sand probe is installed in the center of the line. It is highly sensitive to transmitter system it has. Sand production rates are quantified by combining measured metal loss rates, average sand particle size, and flow data. It's applicable for all field particle sizes and field velocities. Its monitoring is the real-time erosion corrosion data. This slide gives you the sand probe, its benefits and limitations. Benefits are the information gained about sand production supports better reservoir management. Usually in the oil and gas industry, the sand comes from the reservoir and then it travels all the way around the entire system unless it is restricted and separated out somewhere in the production system. It measures the rates from both erosive and corrosive factors. It's a real-time data with high resolution. It enables the erosion rates to be correlated with other process parameters for greater control. Its very rugged design allows for use in severe flow and high temperature environments. It's more effective and highly sensitive. It can be used as wireless. The limitations are consumable because those probes, they are consumed or eroded during their installation and monitoring. The largest, or you can say the snag of this technique is that it cannot distinguish between erosion and corrosion. This slide shows the acoustic sand probe principle and monitoring. Its principle is physical, direct, intrusive online technique. It directly measures the sand erosion by direct weight loss on probe element. Sensor measures acoustic impacts. Noise and the amount of sand particles in water, oil, gas, or multi-phase flow lines. Amplitude of the acoustically detected signal of the colliding particles is proportional to the mass and square of the flow rate as given in there. It monitors the solid particle drifting in the gas or liquid flow, impart a great part of their kinetic energy on colliding with the probes, and cause acoustic pulse sequence like a noise. Frequency of noise spectrum is in megahertz magnitude. Probe is placed perpendicular to the direction of the flow. From motional speed, solid material quantity flowing through is determined. Speed of solid particles calculated from frequency of vortex. Vortices are produced around the probe, immersed in the flowing liquid and gas, periodically detached from the probes. Frequency of vortex is proportional to the corrosion rate. This slide shows acoustic sand probe benefits and limitations. Benefits: this technique is fast, responsive, and sensitive, easy and reliable. Inexpensive installation. It can monitor the actual erosion rate continuously. It gives you the real-time data. No maintenance for detector. It's a wireless technique. Limitations are consumable because the probe will keep on losing its weight and integrity. It can be limited to the sand particle size of more than 30 to 40 micron meter. Sand velocity is said to be less than 0.1 pounds per million standard cubic feet. The right side slide also shows that how the probes or where the probe is stored in a place where the impact of the sand particles or the resultant erosion is the highest in the pipeline. This slide shows the hydrogen probes monitoring technique, its principle and monitoring. Its principle is physical indirect technique, is intrusive, non-intrusive, online. Hydrogen probes are used where hydrogen is produced as a result of corrosion. Its intrusive type requires service valve and retriever. Non-intrusive type is a patch probe welded to the exterior of the pipe or vessel or patched to the exterior pipe or vessel with a removable patching system. This monitors the hydrogen flux and built-up pressure. The configuration shows that how the hydrogen probe is installed and how it looks like. This slide shows a hydrogen probe benefits and limitations. Benefits: the thin wall sensing element allows for quicker response times. Is rated for pressure up to 6,000 psi. Is removable under system pressure. Internal temperature gauge allows compensation for temperature and variations. Limitations: it's qualitative and quantitative. Material structure dependent, material composition dependent, temperature dependent, time dependent. This technique does not give you the direct corrosion rate. It gives you the relative change of the hydrogen pressure, and from the hydrogen pressure you can easily calculate how much there has been a corrosion of the carbon steel or any representative metal which is corroding with the active hydrogen formation during the corrosion.